I guarantee you, in the next few minutes, you will learn something that you did not know before. Back in the days, in the late 17th century, a British guy called Newton proposed that the apple was not falling on the earth. Instead, apple and earth were falling at each other. So, earth moves towards the apple a bit and apple moves a lot towards the earth. Not just qualitative interpretation, he found the quantitative relationship, a formula to measure force of attraction between any two objects. This formula is helpful in many ways. We can plan the thrust of an aircraft, measure mass of earth, or with how much force it is pulling the moon. And more importantly, it can explain the planetary motion, how planets revolve around the sun. By early 19th century, about 120 years later, someone predicted that light would be deflected when passing a heavy object. Starlight, when passing by the sun, was estimated to be deflected by about an arc second. Arc second is an angle that measures degree of deflection. By the early 20th century, about 100 years later, someone formulated a method to test this out. One challenge though, we need a total solar eclipse for testing. The idea is to look at the star position during the eclipse and compare it to the expected position. In 1912, British and Argentinian teams went to Brazil. Full eclipse stays only for 2 minutes. They prepared for months for the day and they focused their telescopes and cameras. But the weather did not permit. They could not get a good view of the stars due to clouds. Next eclipse was in 1914. There was a twist to the 1914 testing. Back in 1905, a young guy, about 25, Albert Einstein, published the theory of relativity. He wrote many papers that captivated public imagination. Theory of relativity has some interesting findings, such as the relationship between space and time. Einstein expanded the theory of relativity to include gravity. As per his calculations, by 1914 or 19 around that time, starlight would deflect about 2 arc seconds. There was a difference of about 1 arc second compared to the calculations using Newton's formula. You know how much of a difference was that? It was so minuscule that you can shoot a golf ball from about a kilometer away, even if you change the angle by 1 arc second. It is not much, but this difference means that only one equation is right: Newton's or Einstein's. Are Einstein's equations just a fancy talk about the time space continuum, or do they explain the nature and gravity more accurately? Now, the measurement is more significant than ever before.